Going ahead, the peptides. What are peptides? You know the peptide bond is simply a CONH bond. So, how it is formed? The bond CONH is formed by the condensation of COOH of one amino acid with NH2 of another amino acid. A simple reaction by the elimination of water, you will get CONH bond. But remember, peptide bond synthesis, though it looks easy, it is not that straightforward. You can't just mix one amino acid with other amino acid with some coupling agent, you can't just make CONH. This removal of water is not that easy the way it is written here, because you can't just synthesize peptide bond by just mixing these two amino acids. So, what we have to do? We have to follow some steps. That is why we need some protecting groups for amines and acids. So, there are different types of protecting groups. What are the protecting groups? From the term you understand, protecting groups are nothing but they protect. So, they protect certain groups to avoid some unwanted reactions, or it may be some side reactions. So, it takes care of unwanted reactions and it protects certain groups at certain stage and allows the further reaction to go ahead. So, from the definition, what you understand, these are the groups which protect amine part or the acid part in order to carry out the reactions efficiently, and it can be removed after the reactions. If you want to see N protecting groups, see in the syllabus there are separate N protecting and C protecting groups. N protecting group, here it is nothing but protecting group used for NH2 or NH, amino protecting groups. Not only N, I mean do not misunderstand with the term. So, N protecting is nothing but protecting groups used for amino groups. So, these are the groups which protect amine part and makes the other reaction, other part of the reactions at the molecule will be facile after protecting NH2 or NH, and at the end this can be removed without disturbing or without interfering with the other parts of the molecule. The best examples is Boc anhydride, of course, you can see the structure. So, it is tertiary butyl group and it is a carbonate group at the center. So, anhydride it is, so you can easily break with the presence of water or dilute HCl, and you have benzyl chloroformate, it is called CBZ chloride, CBZ chloride, and acetyl chloride CH3COCl, you have tosyl chloride and methane sulfonyl chloride. Again there are various examples. These are some of the examples which you can remember from the examination point of view. Then you have protecting groups for COOH. So, C protecting means what here? It is protecting groups for acids, COOH protecting groups. Again, why we are protecting? Because again COOH being a labile group or very much reactive, so it causes intervention. It makes intervention during the reaction of the other part. That is why COOH group has to be protected in order to carry out the reaction at the other part of the molecule. So, remember there are various protecting groups for COOH also, but very commonly used in peptide synthesis are acetyl chloride, some alcohols, because you can make esters and you can easily remove by simple hydrolysis, and you can easily make acetyl here and then you can remove it by hydrolysis. And some other groups can be used, but removal is bit difficult. You can see how peptide can be synthesized by making use of these protecting groups and how it can be efficiently converted to some peptide bond formation. You can see formation of CONH here. So, this is the general peptide synthesis scheme. You have, you are taking amino acid wherein COOH group is protected, NH2 group is NH2 group is outside here projecting. This whatever these lobes, what you can see here, they indicate the protecting groups. At the end of the reaction, see the last product which you have amide, so it does not have any lobe here, that means protecting groups are removed. So, please note this point. So, in the beginning you take one amino acid and you protect COOH part of it and NH2 part is available. You take another amino acid wherein NH part is protected. So, PG indicates protecting group. So, these lobes can be protecting groups or it is simply something wherein amine is attached to it. You must have heard about the polymer. Some polymers with NH2 is also fine, but you can consider this as protecting group or as a polymer, or you can simply say NH2 is solid supported. It is supported over something which may be a polymer or some solid support. So, or I consider this as a protecting group, simple. It is very easy to understand for you at this stage. So, if you consider these slopes as protecting groups, again another protecting group for NH. So, remember, before carrying out the reaction, both suppose you have two amino acids, I will explain it in the next example. You have two amino acids, one amino acid COH has to be protected and NH2 should be free. In the other amino acids, COH should be free and NH should be protected. So, now in one amino acid NH2 is free, in another amino acid COH are free. Now, you have to couple this to get CONH bond. Okay. Now, you start the reaction, you have coupled with this. So, you have the formation of CONH bond, both the protecting groups available on the same molecule. Now, deprotection of this, correct, you have deprotected it, and then you couple with another amino acids where it is protected. So, at this stage now, from this reaction what do you understand? So, this lobe is something polymer supported. So, how you started the reaction now? Polymer supported this NH2, now it is reacted with one amino acid to give CONH bond. Now, you have deprotected this part. Now, in this case NH2 is now available. Now, with this NH2 you couple with another amino acid COH of this, and wherein NH is protected here. See here, now in this molecule NH2 is available for coupling, and in this molecule NH is protected and COH is available for coupling. You have done the coupling reaction. Coupling is nothing but simply the combination of or removal of water and formation of this CONH bond. So, you have prepared this amide and now you do the deprotection of this. At the end you do the cleavage of this polymer support or something which is supporting NH. So, remove this, so you will get amide. So, this is an amide formation. Okay, this is how peptide synthesis is done in general. In your syllabus there are only two examples to be discussed, that is synthesis of gly-ala. It is nothing but glycine and alanine. So, you have made a peptide bond by coupling glycine and alanine. So, how will you do this? You have to start with glycine and alanine, you have to couple and form a bond for glycine and alanine, that is CONH bond between these two. Okay. So, you start with this. So, you have one side we have alanine part, another side we have glycine part. Okay. In this example you can see it here. So, glycine and alanine. So, you have alanine part. So, that is nothing but CO, this one NH, this CH3 and RCONH, you can call RCONH CH3CO part, and from the glycine part you have NHCH2COCH3. Where is the amide bond? CONH. This is the amide bond formed between these two. Okay. Now, you start from alanine, that is NH2 CH3, correct, and COOH. So, that is NH2, that is CH3 COOH. Okay, this is alanine. You started with alanine. Alanine you have to protect either COH and NH2, and again here in the glycine you have to protect either COH or NH2. If you are protecting NH here, then you have to protect COH here, because for coupling reaction using DCC, DCC is a coupling reagent. Structure of DCC is which is a dicyclohexyl carbodiamide. You have dicyclohexyl group and carbodiamide group in between. So, then the CONH NH, you will get urea derivative as the end product, which can be easily removed by column. You can also use EDCI. So, EDCI is having this structure, it is a modified reagent of DCC. The advantage of using EDCI, it is a salt, is over DCC is, this goes in water after the workup. when you do workup after the amide bond formation, you just add water or dilute HCl, then it easily goes out in water, so you get the end product bit clean. Okay. So how this coupling is carried out? So you can start with glycine or you can start with alanine, whichever is okay. So if you see it here, you started with alanine. Alanine NH is protected, it is converted to amide group, that is CONH. You reacted with RCOZ, RCOCl or whatever, or RCOBr, whatever it can be. So you will get NHCOR. Now this NH2, whichever is reactive, has become unreactive now because it is amide. You know, amides are not that reactive or very less reactive compared to amine. So now this is this group you made very stable, you converted labile group into stable group. Now COOH projecting from this molecule is available for coupling. Now you take the glycine, in glycine what you have to do, you have to protect COOH. So how will you do it? The best way to protect COOH is convert acid to ester and keep the amine part intact. So you have converted acid to ester. How did you do this? You react with the methanol in the presence of some acid, or you react with ethanol, any alcohol, but it should be easily be removed at the end of the reaction. So you have carried out this reaction and then you maintain the pH higher to in order to keep this basic. Okay, just you have neutralized this acid. See, note down this because these are some of the important steps in the practical chemistry. Here you have maintained the pH lower than 7 at the end of the reaction during the workup. Why? Because you have to generate this acidic group. See the step, initially you reacted with RCOCl, that whatever the side product HCl or something comes out will be making this acidic and will be making this protic, okay, protonated. That time pH goes higher because you have it is neutralized by some base because you have to add some base here. So NHCO it is converted to. Then you converted the molecule into acid instead of keeping it in CO minus. So you have acidified the solution. So convert this into COOH. So that COOH should be available for this coupling reaction. Here you increase the pH in order to make this amino group available. That means you have made it basic. Okay. Now look at these two groups, protected alanine and glycine. In protected alanine, so you have COOH and C protected glycine, you have NH2 group. So this is N protected alanine, this is C protected glycine. Hope the terms are clear for you because N protected means what? It is NH2, that is NH2 part of this alanine is protected. That C protected glycine means what? COOH part of this is protected. That is what I had stated in the beginning. So you have now NH2 and COOH open for the coupling. You added DCC in the presence of dichloromethane and some base like you can add some tertiary amine base like pyridine or triethylamine. And the reactions you have carried out to give the coupling reaction. The coupling is nothing but formation of amide bond between this NH2 and this COOH. Mechanism is out of syllabus, that is why I am not discussing it here, but in brief I am explaining that is formation of this amide bond. So once you got this amide bond, now the next job is to remove your protecting groups, that is RCO part and ester part here. Okay. So you remove it by some acidic or basic condition. So this you can hydrolyze by base, this you can do it by acid, but make sure that time this part is not removed. Okay, this part is not hydrolyzed. So you will get alanine and glycine. You can see in examples in detail. You have glycine react with Bock anhydride. Okay, this is the best example to illustrate how exactly you will get glycine alanine for amide bond formation. Glycine you have protected NH2 with Bock anhydride, so NH Bock. Now you convert this into COCl. Okay. Now what you do? Next you can add alanine to this. This is also called acid chloride method. Acid chloride method you can call it as, because you are using acid, you are converting acid into chloride, that is why it is acid chloride method. Acid chloride method. So it is bit facile compared to the earlier one which you have seen here. So you are just converting amine into acid chloride, but protected acid chloride. Then you add the alanine. So glycine you have taken and converted to acid chloride, protected acid chloride of glycine. Then you add alanine. So now alanine, which part will couple? NH2 will couple with this COOH. See, this remains intact because there cannot be bonding between this and this. Even if it happens, OH attacks, then again it goes back. So NH2, which is more nucleophilic, will attack here, not the COH-OH part. Okay. So you will get CONH bond. Then what you do? Just hydrolyze this NH BOC. Remove the BOC using trifluoroacetic acid. You will get glycine alanine. So if you think in the examination this is bit complicated, that is using DCC coupling and removing using some other groups. So you can remember this acid chloride method, which is very facile and bit eco-friendly because the side products are all going in water here. All the side products what you see, SOCl2 will be converted to HCl and sulfur dioxide. Sulfur dioxide will go out and HCl will go in water, and you add base again, that will go in water, and trifluoroacetic acid again can be removed by some basic alkali solutions or just by water. So you will get amide out. This may be water soluble sometime, but by repeated treatment with some solvent, so you can you will be able to extract it in organic solvent. Okay. And another synthesis is you have synthesis of glycine. So the same method you can apply here. You have taken glycine, converted to NH BOC glycine. Okay. Amine protected here, BOC protected amine. Now you convert this COH part to COCl, then you add another mole of glycine to this. Now CONH bond is formed. Remove this BOC part, so you will get glycine. So how will you do the reaction? In an RB or round bottom flask, you take glycine, add DCM BOC anhydride, make sure it is dry, do not add water, and BOC anhydride you take this in dichloromethane, and triethylamine you add 0 to RT you can maintain, because BOC anhydride when you add it is a bit exothermic. Then you slowly add BOC anhydride from the top in the form of solution, because BOC anhydride is solid compound. You have to make a solution in DCM, or you can directly add the solid, but make sure while opening and adding, because it is bit exothermic, make sure you have maintained the temperature 0 to 0 degrees Celsius. Then you keep it for 15 to 20 minutes, bring it to room temperature. You have this, do the workup just by washing with sodium bicarbonate, dilute solution of sodium bicarbonate. You get this, take out this and react with thionyl chloride. You add thionyl chloride, you can take this in DCM or just like that also you can take, add thionyl chloride. You will get acid chloride. That acid chloride you keep it in the same flask, keep it in the same flask, do not remove that, because most of the side products or gases here go out. You can just concentrate and keep it in the same flask, remove the solvent and keep it in the same flask. Add glycine, you can add a solution of glycine, or in the solid peptide synthesis you have to add another amine in the presence of some coupling agent, that is a different topic. I do not discuss it here. So you add glycine, then the coupling reaction takes place in the presence of some solvent. So at the end you add TFA to the same solution, stir it for 15 to 20 minutes, you will get glycine. Just do some basic washing, so you get rid of TFA. So whatever the solid comes out, you will be lucky if you get this in the form of solid. So then you just do some acid base purification, so you will get this compound. Okay, this is how you do the synthesis of glycine. You do not have to remember the practical part from the examination point of view. You just remember how the scheme is performed. Just take glycine, convert it to BOC protected glycine, then you react with thionyl chloride. you will get acid chloride, then you add glycine. CONH bond, once it is formed, you react with TFA or dilute HCl to get rid of POC. Okay.